Dear colleagues, to thank you for the opportunity to speak at this conference. It's your pleasure to present you Paper Development and National Aviation University machine learning driven your mapping for automated detection of nutritional deficiencies and disease in wheat. This report focuses on the development and implementation of machine learning-based algorithms for plant condition classification using your captured images. It explored of the source of visual data obtained during drone flights and methods of processing this data to diagnose plant health. Additionally, the report highlights that practicals in applying artificial intelligence and your technologies to support decision making in agriculture, particularly in taking nutrient definition and decrease related damage for timely and effective teams. Motivated by this advantage, this study explores the integration of UI technologies with modern machine learning approaches to evaluate automated plant condition analysis. We propose a novel algorithm that processes aerial imagery captures by UIs to assess the state of vegetation, identify critical zones affected by nutrient deficiency or disease, and supports real-time decision-making for prompt intervention. The combination of your mobility and driving analysis provides us a powerful adaptive framework of intelligence monitoring and rapid response in modern precision agriculture. Modern agriculture faces growing challenges such as climate change, increased population, and the need for sustainable food production. Ukraine, being one of the leading grain producers, places a particular focus on winter breed wheat, which covers up to 14 of the total crop area. However, the aid of this key crop is only limited by plant diseases, nutrient deficiency, but unfavorable environmental conditions which can lead to loss of up to 70 depending on the severity of the stressor. Our work presents all ML-based algorithms that process your emergency to automatically detection critical areas affected by disease or nutritional stress. To ensure timely and accurate monitoring of the crop condition, we developed an intelligence data processing pipeline based on your imaging and machine learning technology. This process begins with continuous capture of high-resolution RGB images using a camera mounted on the unnamed area vehicle. At this final stage, a detailed condition map of the fight is generated along with flight route for the touch application of verticals and protective screens. All captures images is automatically standardization into uniform column space and the sizes of 50 to 50 pixels. Each revised image is flattened into a freeze vector of 7,500 elements were served as an input for the random forest classifier. This classifier is trained iteratively with model accuracy evaluated on the control signal after each training loop. It is algorithm workshop. This block diagram algorithms of plant state monitoring, classification, and AI flight route information. Firstly is starting process and formation is training data sets. It's collection of flight images employed, including samples of plant conditions related to typical disease symptoms and themes of neutrinos definity. This is preprocessing and image undergo normalization resizing to prepare the analysis. You have light and data collection is UA road is used to capture file image and coordinate data. Image processing, raw image from US is transformed into vectors for machine learning, model training, condition mapping, data export, and accuracy evaluation. These algorithms allow for scalable, cost-effective, and timely plant health assessment, making these valuable tools for precision agriculture and rapid decision making in the field. As a preliminary stage is randomly assigning class label to test its pipeline performance. This label includes 0 for healthy plant, 1 for the plant is need fertilizers, and 2 for plants is need chemical treatment. As this can to see in detail in figure, this in the future we plan to replace this conditional makeup is part of same automatic makeup, and this data to speed training 18 and test 20 sample for once before training cycle. In the figure of 10 to 10 quadrat is represent a file that show the total and vertical alignment is normalization from this dimension, and right size is color scale is this show. The scale represents the color indication of the plant state. Cycle training is the random forest classification what condition under 3 case scenarios, 10, 100 and 1000 epoch. This allowed us evaluation its classification ability to generalize plant condition weather other various duration of learning. This 10 epoch during the interval phase epoch 1-3 model accuracy flexibility between 40 and 65%. However, as the picture in figure 1, this accuracy was highly estimable. By this 5 epoch, performance rate of around 40% demonstration that such a small number of iterations is insulated to extract stable. These two scenarios is 100 epoch. In the scenario with 110 epoch, and during the first 15 epoch, classification accuracy flexibility between 64%. By the 3 epoch, model stabilization reached an average accuracy of around 56. For the main training periods, 3100 epoch accuracy state in 53-57 range, which looks amplitude gradually increase. This platitude indicated that the classification has reached its generalization limit under this training configuration. And this scenario 3, it is 1000 epoch, this extended training scenario, and have epoch 3 20 accuracy increase from 40 to 45 with significant verification, and epoch 20 to 200 rapid linear growth is accurately was observed, peaking at 65 with decreasing variant, and epoch 200 to 1000 the accuracy fluctuated at 60-62 with minimal fixation, suggesting that the model has fully learned of meaningful pattern present on this data. Uh, to train this model, we use a real picture of the field of trichum avis tutum. The visual diagnostic was made using the UAS with camera mounted on it. The picture to trichurium austium that contain characteristic fracture is a symptomatic of damage by decrease of stability from a loss of neutrium were using as well. The symptoms are mostly related as change in this coloration of the organs and as change into general trend appearances. This allows to classify objects in green class in healthy, in yellow class in need fertilizers, and the red class in need chemistry. The result of the reach also demonstrate the potential of the integration of modern technology, including UAV, artificial intelligence, and machine learning, into the agricultural field of people activity, showing the advantages of considering technology for automatic monitoring and diagnostic of the plant and quick response to its action. Thank you.